Optics OSN equipment, including Optics OSN 7500-2, 7500, 3500, 1500, belongs to hybrid SNTP series products, which have a unified switching architecture and can function as a packet or TDM devices. Through collaboration, Optics OSN equipment is end-to-end used for access layer to backbone layer of a MAN. Optics OSN 7500-2 is mainly used on the backbone layer of a MAN. A single subrack supports a maximum of 320G packet capacity, 360G SDH higher order, and 80G SDH lower order capacity. Optics OSN 7500 is mainly used on the backbone layer of a MAN. There are two types of Optics OSN 7500 subracks, namely Common Subrack and Type 3 Subrack, 2300 watts. The two types of subracks support different power boards, so their power consumptions are different. A single subrack supports a maximum of 160G packet capacity, 360G SDH higher order, and 40G SDH lower order capacity. Optics OSN 3500 is mainly used on the aggregation and backbone layers of a MAN. There are three types of Optics OSN 3500 subracks, namely Common Subrack, Enhanced Subrack 1100 watt, and Type 3 Subrack 2300 watt. The three types of subracks support different power boards, so their power consumption are different. A single subrack supports a maximum of 160G packet capacity, 200G SDH higher order, and 20G SDH lower order capacity. Optics OSN 1500 is mainly used on the access layer of a MAN. There are two models of Optics OSN 1500 products, namely Optics OSN 1500A and Optics OSN 1500B. A single subrack supports a maximum of 8G packet capacity, 60G SDH higher order, and 20G SDH lower order capacity. Optics OSN equipment can be installed in ETSI and 19-inch cabinets. ETSI cabinets can be 300 mm or 600 mm in depth, while the 19-inch cabinet has been discontinued. Different OSN devices are installed in different cabinets. A DC Power Distribution Unit, PDU, is installed in the top of a cabinet and supplies power to the equipment. Block A and Block B provide a backup for each other. Optics OSN equipment supports various types of PDUs. This table provides how each product supports PDUs. Optics OSN equipment uses an uninterrupted power modules UPM system to support the access of 110 volts or 220 volts power. The UPM power conversion system converts 110 volts or 220 volts AC power into -48 volts or -60 volts DC power and supplies DC power to the equipment. An Optics OSN 7500-2 subrack consists of the upper layer and lower layer. The upper layer has 20 slots and the lower layer has 18 slots. There are two other slots for fans. Each slot supports different access capacities in packet mode and TDM mode. A single slot supports a maximum of 20G access capacity. An Optics OSN 3500 subrack consists of the upper layer and lower layer. The upper layer has 19 slots for interface boards, and the lower layer has 18 slots for processing boards. There are 3 other slots for fans. Each slot supports different access capacities in packet mode and TDM mode. The cross-connector board type also determines the access capacity of a slot. An optics OSN 3500 sub-rack consists of the upper layer and lower layer. The upper layer has 19 slots for interface boards, and the lower layer has 18 slots for processing boards. There are 3 other slots for fans. Each slot supports different access capacities in packet mode and TDM mode. The cross-connector board type also determines the access capacity of a slot. An optics OSN 1500A sub-rack has only one layer providing 12 slots. 2 slots can be divided into 4. In addition, there is another slot for fans. An optics OSN 1500B sub-rack has 2 layers. The upper layer has 6 slots for interface and power boards. The lower layer has 11 slots before division and 14 slots after division for processing boards. The access capacity of slots is different before and after slot division. Slots can only be divided before delivery. Do not divide it personally. By function, the boards of optics OSN equipment can be classified into cross-connect and system control boards, packet processing boards, packet interface boards, dual domain bridging boards, hybrid line boards, SDH boards, PDH boards, EOS boards, ATM boards, PCM boards, WDM boards, optical amplifier boards, and dispersion compensation boards, auxiliary boards, and power boards. Cross-connect and system control board integrates cross-connect, system control, and clock units to provide communication control, service scheduling, and clock processing functions. Packet processing board provides access of data packets and implements bandwidth management and packet switching. Packet interface board provides input and output ports for various signal cables connecting to packet processing boards. Dual Domain Bridging Board bridges Ethernet services between the TDM and packet domains. Hybrid Line Board transmits packet and TDM services in a big OTU pipe so that granular services can be transmitted more efficiently. SDH board transmits SDH signals by performing OE conversion and processing overheads of STM-in signals. PDH board encapsulates and maps incoming PDH services and cross-connects them to the SDH line for service transmission. EOS board encapsulates and maps incoming ETH services and cross-connects them to the SDH line for service transmission. PCM board enables the SDH network with the access and scheduling capabilities of PCM services. WDM board multiplexes and demultiplexes optical wavelength signals, thus saving optical fiber resources. Optical amplifier and dispersion compensation board amplifies optical signals and provides dispersion compensation to save slot resources on a sub-rack. Use an external COA as the optical amplifier. Optics OSN 3500, 7500, 7500-2 with fans provides an air channel through which air flows from bottom to top to dissipate heat. Optics OSN 1500 with fans provides an air channel through which air flows from left to right to dissipate heat. The figure shows different power consumption policies mapping different power consumptions of sub-racks.